Morning, calc fans. How we doing on this fine Monday morning? A little cloudy out there now. It was a little sunny. A little sun felt warm. A little chilly though. It was a great weekend. The weather was nice and warm. Felt like a little bit of summertime out there. Hope you enjoyed your weekend. Hope everybody's doing well in your household. Hope everybody's feeling well in your household. We have two more topics to cover. Two more topics in calculus to cover. We will cover them this week. We have integration by substitution, which we'll cover today, and we'll talk about some area tomorrow that we will cover. From that point on, we then will do a review sheet and a quiz over the integration by substitution and area. That will be on Friday. Monday will be another review day, and we'll have a chapter 5 test over the entire chapter of integration, and from that point on we will start reviewing for the final and get a final in. So we will get to our final very quickly. We're close to the end. You guys have been doing a very good job. Continue up with the work, stay up with the material, and once again we only have two more topics to cover here, so the end is near. La la la. Today we're going to talk about integration by substitution. If we take a look at this function right here, f of x equals x squared plus 5 all to the 9th power, and we want to calculate the derivative of this function. If we calculate the derivative of this function, we have to remember we have something to next, but we have to apply what we call the chain rule. Okay, so the 9 will come out front. We keep everything inside the same, and we subtract 1. Remember, when we deal with the derivative, we subtract 1 from our exponent, but then we have to remember to go inside and take the derivative once inside. Once again, that is the chain rule. So we have a value of the derivative of x squared plus 5, so we have 2x plus 0, or just 2x. So combining these together, we get 18x times x squared plus 5 to the 8th power. In mathematics, we have developed, mathematics was developed, so we have a process that we do in mathematics, and a process that will undo the process that we just did. Okay, so what we've done here is we've taken the derivative. And what we've learned, to undo the derivative, we can take the antiderivative to be able to undo the derivative. But the problem we run into is if we take the antiderivative of this, how do we do that? Well, if I wanted to, I could use my Pascal triangle and my binomial expansion and expand this out, which is, oh, ouch, that would hurt. So I don't know if we're going to go about doing that. So what could we do to be able to take the derivative of this, or the antiderivative of this? How can we integrate, how can we take this and get back to this up here? Well, that is what we use, what we use is called a substitution principle. And it's called integration by substitution. There's ways of undoing the product rule, quotient rule, chain rule. There's different techniques of antiderivatives. We will just go through one, and that is integration by substitution. There's integration by parts, which would undo the product and the quotient rule. What we're going to deal with is integration by substitution, which undoes the chain rule. What we do in this manner is we take a look at what is our quantity. What thing is being quantified here? And let's let u equal whatever value is being quantified, which is x squared plus 5. Now I'm not taking to the 8th power, just the value that's being quantified. So if you have a square root, you're going to look and take what the value, or that we're going to let u equal what's inside the square root. Okay, so if I take a look at this, u equals x squared plus 5, and let's take the derivative with respect to x, du dx. So what we have here is a value of 2x, and what we're going to look to do is we're going to look to substitute and transform this antiderivative from x into the idea of u. We've already said this is going to be u here. Dx, we had to get rid of the dx. Well, we had to change this to a du. Well, how do we change this to a du? Well, if we take a look, if we multiply both sides by dx, we have du is equal to 2x dx. And then dividing by 2x, what this will give us is dx is equal to du over 2x. So if we make some substitutions here, and I rewrite my antiderivative, I still have an 18x here, but x squared plus 5 we said is equal to u, so we have times u to the 8th, and then dx is equal to du over 2x. So looking at what we have, I have an 18x and I have a 2x. These will cancel, giving us a value of 9. So now my antiderivative turns into 9 u to the 8th times du. Not times du, just du. So we have 9 u to the 8th du that I could take the antiderivative of. Well, now I want to take my antiderivative of 9 u to the 8th du. My u here tells me I have to have the variable u here. My x here tells me I'm dealing with x's with all my properties. So I'm going to take my antiderivative, which means now I add 1. So we have u to the 9th. And then we take our coefficient and divide by our new exponent. And don't forget your plus c, because I have no limits of integration. We have an indefinite integral. So what we are left with is u to the 9th, 1 u to the 9th plus c. And if I do my back substitution here, u is equal to x squared plus 5. So we're left with x squared plus 5 plus the value of c, which is, let's get a 9th power here, which takes me back to what I started with, integration by substitution. It's almost like having a magic wand, Alakababa, Shishkumba, poof. We made it back to where we started. Let's take a look at another one. We have the antiderivative of sine of x to the 4th cosine of x. Well, what I'm going to do with this is use my definition of what does it mean to have an exponent here. Well, it means I have the sine of x all to the 4th power. I take whatever the sine of x is to the 4th power. We take a look at what's being quantified here. What's being quantified is the sine of x. So let's let u equal the sine of x. So du dx is equal to the derivative of sine, which is cosine of x. We can once again multiply by dx, but then we're going to divide by the cosine of x. So we're left with dx is equal to du over cosine of x. So making my substitutions here, this is the antiderivative. Sine of x we said was equal to u to the 4th times the cosine of x times du over cosine of x. Well, what happens nicely is the cosine of x's, they move to Texas. So So we have the antiderivative of u to the fourth du. Once again, we're not done yet. We have to now deal with our antiderivative, but hopefully we're getting a little bit better at this. Add 1, so we have u to the fifth. We have a coefficient of 1, so we have 1/5 u to the fifth. And don't forget your plus c. Then your final step is to back substitute and get rid of the u by putting in the sign of x. So we have 1/5 sine to the fifth x plus c. Now mind you, what we are taking the derivative of, or what we're doing here with our substitution. We're finding a value, we're taking a substitution. Or we're finding a value and set it equal to u. Then we're taking the derivative. Now remember, when we take the derivatives, what happens to our degrees of the polynomial or exponents? Well, they decrease. They get smaller by 1. If I have x to the fourth, I take the derivative of x to the fourth, I get 4x cubed. The derivative of 4x cubed is 8x squared. My exponent continues to decrease. So when I'm looking at this, I want to be able to choose one of these to be equal to u. Well, let's let u equal to t squared minus 5t plus 2. Because we're going to be taking the derivative of this, so we're going to be decreasing our degree by 1. So go ahead, du dt, taking our derivative here, comes down to 2t minus 5. And once again, we're going to multiply by dt, but then divide by the 2t minus 5. So dt is going to equal du over 2t minus 5, which so happens to be in our numerator. So we have the antiderivative 2t minus 5 over u times du over 2t minus 5. And once again, what so happens nicely is the 2t minus 5s, they go bye-bye. So we're left with the antiderivative of 1 over u du. Now, once again, common mistakes occur at this point is they do this, students do this and say, I'm done, I've done my canceling. No, we still have to take our antiderivative. Well, we have to remember the antiderivative of 1 over u. That's equal to the absolute value, or I'm sorry, the natural log. And I'm going to put an absolute value there because we need to make sure this absolute value or this natural log value stays positive, because I have t squared minus 5t plus 5 plus 2. If I put a value in here that gives me a negative, I'm going to have a problem. If I have a value of 1, I have 1 minus 5 plus 2, that gives me a negative 3 or negative 2. So we have a problem. So we have the antiderivative to give me a natural log absolute value of u plus c. And then once again, back substituting, we have natural log of t squared minus 5t plus 2 plus the value of c. We have 12x square root of x squared minus 3. Let's let u equal what's being quantified, the x squared minus 3. So du dx. What I want you to do is I want you now to go through and finish this problem. So I want you to hit the pause button, finish the problem, turn it back on, and then check your answer. Okay, so I got you started here. Hit your pause button, finish the problem, turn it back on. we have 2x, so dx is going to equal du over 2x, which gives me the antiderivative of 12x square root of u times du over 2x. So the 12x and the 2x cancel to give us 1 and 6. So we're left with the antiderivative of 6. Oopsie. The antiderivative of 6 u to the 1/2 du. Now when we're taking the antiderivatives, we have to add 1. So we have 6 divided by 3/2 times u to the 3/2, once again plus c. So we have 6 divided by 3/2, which means I need to flip and multiply 6 times 2/3. This gives me a value of 4. This gives me a value of u square root of u plus c. But once again, make sure you do back substitute. So we're left with 4x squared minus 3 square root of x squared minus 3 plus c. We'll go down to this last one here. Now on the last one here, it's a little bit trickier. We have the antiderivative of x plus 1 and x square root of x minus 1. So let's let u equal x minus 1. So du equals dx, because my derivative here is just 1. So if I make my substitution, we're left with the antiderivative of x plus 1 square root of u du. The problem we run into here is everything else that we've done up till now, we've been able to cancel out this other variable of x. In this case, we can't. So what do? That's a thinker. Well, if we go back to our initial statement, u is equal to x minus 1. What would x equal? Given this statement right here, if u equals x minus 1, x would equal what? Well, if I add 1, this would equal u plus 1. So still maintaining my substitution, we have the antiderivative. Now we have u plus 1 plus 1, because we're taking this x out here, replacing it with what x is equal to, u plus 1, and then times u to the 1/2 power du. So we have, let's see here, the antiderivative of u plus 2 times the square u to the 1/2 power du. Using our distributive property, we're left with the antiderivative of u to the 3/2 plus 2u to the 1/2 du. Now we're set to take our antiderivative. U to the 3/2, we have to add 1, and this tends to be a confusing thing for students because now what we're doing is we're putting derivatives and integration in the same type of problem. and you forget what I have to do, add or subtract the value 1. When I'm taking my derivatives, I need to subtract 1. When I'm taking my antiderivatives, I need to add the value of 1. So we have u to the 5 halves. We have 1 over 5 halves plus u to the 3 halves, 2 divided by 3 halves. What this tells me to do, this tells me to reciprocate, so this turns into 2/5 u squared square root of u. This turns into 4/3, so we have 2 divided by 3 halves, which is 2 times 2 over 3, which is 4/3 u square root of u, and don't forget your plus c. And finally, making your back substitution, we're left with 2/5 u is equal to x minus 1 squared square root of x minus 1 plus 4/3 x minus 1 square root of x minus 1, whoopsie, square root of x minus 1 plus c. Well, keep on putting a plus in there. There we go. This is fine. Some people will factor out. You don't need to factor out. You can factor out an x minus 1 square root of x minus 1. You're fine where we're at right now. This is integration by substitution. We'll spend 2 days on this. We'll go over some additional problems tomorrow because it is a little bit more involved. We'll start putting limits of integration in there also. And we'll start dealing with that and working with and continue to work with the integrations. I posted a worksheet. I'll post solutions also. Continue to do the good work that you're doing. You're doing a great job. In the circumstances that we are at this point. You've done a nice job up till now. Continue to push forward, continue to work forward. Once again, we're close to being done here. Close to being done. All right, you folks have a great day. I miss you. Wish we were here in class and enjoy the last 3 or 4 weeks together, but we're not here. So I miss you guys. I wish you were around. But we'll make do with what we have at this point. Once again, continue to do the work. I'll post stuff. Adios. Have a great day.